Okay, good morning, afternoon, or evening, everybody. Welcome to the LAADS DAAC Transitioning to the Cloud, an Overview and Data Access Earthdata webinar. This is your host, Jennifer Brennan. It is 2 p.m. Eastern Daylight Savings Time, so we're going to go ahead and get started here. What I'd like to do is begin today's webinar with just a few logistics. To ensure the best audio experience, all participants have been placed in silent mode. So if you have any questions or you have any issues, what I'd like you to do is to enter those into the Q&A panel, and you should see that on the right side of your screen. If you don't, click on the menu, the three dots in the bottom right, and then you can select either the Q&A or the chat. Okay. Today's webinar is being recorded. The recording will be posted both to the NASA Earthdata website as well as to our NASA Earthdata YouTube channel within a week of completion. Once completed, what I'll do is I'll send an email to all of the registrants with recording links as well as a link to the presentation slide deck that's used in today's webinar. As far as timing is concerned, today's webinar will be 1 hour long with 45 minutes allocated to the presentation and live demonstration and an additional 15 minutes for the question and answer period. During this afternoon's event, we will have 2 speakers and 1 Q&A panelist. Our first speaker this afternoon is Tassia Owen. Tassia is the outreach coordinator for NASA's Level 1 and Atmosphere Archive and Distribution System, Distributed Active Archive Center, or LAADS DAAC. She will begin today's webinar with an introduction to the LAADS DAAC. Let me go ahead and actually get us to the agenda here with an introduction to LAADS DAAC and its data holdings. Provide some background information about why the DAC is transitioning to the cloud, discuss benefits to the end user, and also provide a snapshot of the data and services migration schedule. From there, we will transition to our second speaker this afternoon, Scott Longmore. He is a cloud software engineer lead at LAADS DAC. He will discuss what LAADS DAC in the cloud means for you, provide a short overview of the cloud implementation plan, and then transition to a set of demonstrations. The first demo will walk you through the steps of how to download data from LAADS DAC using S3 Direct Access. And then the second demo will focus on how to use Earthdata Search to access the LAADS DAC data holdings in the cloud. And then finally, he'll wrap up this afternoon's event with a quick overview of future cloud work. Once Scott has finished with his presentation and demonstration, we will then transition to an optional final set of polls. I will leave these questions open for about 30 minutes or so that you have time to provide your responses as we go through the Q&A. We will also be bringing in a Q&A panelist, Doug Newman, for this afternoon's event. He is a systems engineer for the Earth Science Data and Information Systems, or ESDIS project here at Goddard Space Flight Center. And he will be available to help address any cloud-related questions this afternoon as we go through our Q&A session. Depending upon the volume of questions that are received, we will extend the Q&A period an additional 15 minutes from end time for those of you who wish to stay on the line, with a hard cutoff, however, of 3:15 p.m. Eastern. One final note about the Q&A, we will try to answer all of the questions within the time allotted, but if we're not able to address your question during Q&A, our speakers will be able to follow up with you offline. And with that, I am going to stop sharing my screen and toss the presenter role to our first speaker, Tassia Owen. All right, Tassia, let me do that now so you can get started.
Thank you, Jennifer. Hopefully you all can see my screen.
I can. Thank you so much. Looks great.
Excellent. Okay. Well, thank you for joining us today as we talk about LAADS DAC's plan to transition to the cloud and give you a little bit of information on how to access that data. Okay. So I know Jennifer just went over the agenda, but just again, thank you very much for your introduction, Jennifer, and thank you to everyone here who has joined us to learn about NASA's Level 1 and Atmosphere Archive and Distribution System, Distributed Active Archive Center, LAADS DAC's data migration to the cloud, and what this means for data users regarding schedule and data access. Today, I will cover why LAADS DAC is migrating its data to the cloud, the benefits of accessing data in the cloud, and an overview of the data product's cloud migration schedule. Scott Longmore, our cloud software engineer lead, will give a short presentation on how the cloud migration is being implemented, followed by a live demo where we will show you how to use Amazon Simple Storage Services S3 Direct Access in the cloud. And he will give another live demo showing how to access LAADS DAAC data in the Earthdata search tool. He'll end by highlighting the future work that is scheduled at LAADS DAAC as we work to fully migrate our data to the cloud. So, what is LAADS DAAC? The Level 1 and Atmosphere Archive and Distribution System, Distributed Active Archive Center, which we, for obvious reasons, call LAADS DAAC because that's quite a mouthful, is one of 12 DAACs within the NASA Earth Observing System Data and Information System. LAADS DAAC primarily archives and distributes data on clouds, water vapor, and aerosols in Earth's atmosphere, as well as key instrument data for NASA, NOAA, and European Space Administration missions. Secondarily, LAADS DAAC serves as a backup source for Moderate Resolution Imaging Spectroradiometer, that's MODIS, and the Visible Infrared Imaging Radiometer Suite, VIIRS, land products. Sources of data at LAADS DAAC are primarily NASA Earth Observing Systems Terra and Aqua MODIS, SUMI NPP, and NOAA 20s, or otherwise known as the JPSS-1 VIIRS instrument. Other sources include some NASA airborne data, as well as data from the European Space Agency's NVSAT, MERIS, which is the Medium Resolution Imaging Spectrometer, and then Copernicus Sentinel-3 SLSTR, that's Sea and Land Surface Temperature Radiometer, and the Ocean and Land Color Instrument, OLCI. But primarily, it serves as a data archive center for the MODIS and VIIRS data that comes from NASA. So, how to access LAADS DAAC data? There are two ways to access LAADS DAAC data from the homepage. So if I actually click back here, you can see on our homepage, there's two little buttons up there called View Data and Find Data. And those will take you to the two current methods that you can access data from the LAADS DAAC website. These are the two primary methods of accessing LAADS DAAC data. View Data allows data users to preview data before downloading, and Find Data is for data users that already know what data they want and the very special naming conventions that are used to locate those particular data sets. But now there's also a third way to access data. It's in the cloud. Yay! This webpage highlights the benefits of using data in the cloud, and that web page is listed right there with the laadsweb.modaps.estis.nasa.gov/cloud, and it's also in the chat. This webpage highlights the benefits of using data in the cloud, has a list of frequently asked questions and information about where LAADS DAAC is in the process of migrating to the cloud. Essentially, it'll tell you what data sets are available now and which ones are coming in different phases. And I'll actually cover that in a couple slides in just a bit. And another important piece of information on this page is the how-to section, which has different instructions and tutorials on how to access data in the cloud. This section will continue to be added to as more methods of access become available. And we'll also be adding today's webinar with the instructions on how to do the S3 direct access and that Earthdata search tool as well to that website. So once that's available, you'll be able to access it there as well as from Earthdata. So why are we migrating to the cloud? It all comes down to big data and how to manage large amounts of data. And it's no surprise that when we talk about NASA data, we talk about big data. So we're working to really manage how we effectively ingest, process, and archive large amounts of data in a cost-effective, flexible, and scalable architecture. So this is all part of how we're working to manage large amounts of data. Okay. So the other reason of why we're migrating is to support the shift to open science. TOPS is our open science group, which is putting together different programming and training so that scientists can learn how to access data in the cloud, how to be able to use data in the cloud, and do all of that analysis in place. You can go to the TOPS website, which is listed there at science.nasa.gov. Open science, transform to open science. Okay. And I'm seeing that people can hear me in the chat. Please let me know if I need to try and speak up as well. So the idea with the TOPS is that their goals are to accelerate major scientific discoveries, broaden participation by historically excluded communities, and increase understanding and adoption of open science principles and techniques. This is all part of NASA's open source science initiative, which is promoting the open sharing of software. So basically, TOPS is the mechanism where you can learn how to use data in the cloud, and that is part of that overarching goal set forth by that open source science initiative. And this year, yay, 2023 is the year of open science. So we're all getting on board by getting our data into the cloud so that we can do more open science. Okay, so moving Estes data to the cloud has numerous benefits for data users. So LAADS DAAC data moving to the cloud will make it have easy access to the data. Data users will be able to access data directly in the cloud, making the need to download volumes of data unnecessary. However, you can still download data if you choose. Rapid deployment. Users can bring their algorithms and processing software to the cloud and work directly with the data in the cloud, which simplifies procurement and hardware support while also expediting that science discovery. It's scalable. The size and use of the archive can expand easily and rapidly as needed. It's flexible. Mission needs can dictate options for selecting operating systems, programming languages, databases, and other criteria to enable the best use of mission data. Reduced redundancy. The use of a common infrastructure with cloud-native services will reduce redundant tools and services, which enables sharing and enforce the use of community standards, as well as uniform policies and processes. And the last one is cost effectiveness. Estes and NASA only pay for the storage and services that are used. So again, it's always trying to use taxpayer dollars as well as we can and responsibly. So along with the scalability benefits, this allows the amount of storage or services to be continually adjusted to ensure that data and services are effectively provided at the lowest possible cost to NASA and Estes. There is also I know that there's some people that are interested in learning more about understanding and managing costs in the AWS cloud. And fortunately, Estes has done a great job of putting together a primer on that particular piece of information. And I think that Jennifer can add that to the chat so that you can access that link if you need to later. And that's also right there here on the bottom. Managing costs in the AWS cloud. If you Google it, you'll probably get to it. Okay, so this brings us to LAADS DAAC's migration phase release plan. And we are here starting with the historical data. And we're now in 2023, which we are using migrating a lot of data this year. It's one of the major years of migrating data. But we started with some of our most popular data sets. And then are moving into some of our less popular data sets, but very useful data sets, especially as people are migrating their usage from using MODIS data to VIIRS data, as the MODIS instruments on board Aqua and Terra are probably nearing somewhere close to the end of life. But as far as I know, they're still plugging along. So hopefully we'll get a lot more on that data continuity record with them. Additionally, the thing I'd like to point out is that there's also going to be hybrid and on-prem access simultaneously with the cloud mode operation. So just because we're moving data to the cloud doesn't mean that you have to abandon how you've been getting data in the past using the on-premises servers from NASA. This is just going to allow more flexibility and help with that transition as we move toward getting all of our data into the cloud. And this graphic is also available on the LAADS DAAC's cloud webpage, which is just listed up there at the top. So along with that, this breaks down those collections as well. This particular table can be also accessed from that page. It'll also tell you our migration status on whether or not those data products have been migrated, or if they're in progress, or if we haven't gotten to them yet. And as you can see, you know, some of those aren't even slated until 2024. So, and then we have additional tables that break down what data products are actually migrated, as well as what mission period or period you can access data for those data sets. So this is phase 1. We have phase 1.1, 1.2, and 1.3, and all of these data sets are available from these different collections. It also tells you the archive set number. So some of you that might be using that find data tool, that's part of that naming convention, which does make it easier to find some of that data at some point. Additionally, as you can see here, the mission periods that are listed are different for the mod versus the mid data sets. And that is because mod is for Terra and mid is for Aqua. And Terra launched in 1999 and started collecting data in 2000, whereas Aqua wasn't until 2002 in collecting data starting in April. Okay. So at this point, I am going to turn over the mic and the presentation to Scott Longmore. So I will end sharing my screen and he will then take the screen.
See that. Can everybody see that?
Yes, I can see it, Scott. Thank you.
All right. So yes, I'm Scott Longmore, the LAADS DAAC Cloud software engineer lead. I've been working on this project with the LAADS DAAC teams since about 2 years ago. And we've started this migration process of these data sets. So I'll go ahead and kind of give an overview of the architecture. So right now, LAADS DAAC Cloud Architecture is a hybrid on-prem cloud system. Essentially, we are sending all the granules for phase 1 and starting phase 2 through new Kubernetes master client or server on the on-prem systems to a EKS client on the cloud. And then we are using a system that is being developed. A lot of DACs already currently use this. It's called Cumulus. We're not using all the capabilities of that yet, but we will be soon in the next year utilizing the full capabilities of Cumulus. Right now, we are currently using the T distribution, which is the way to access the data through S3 and other methods. We are also sending our logs to 3 central our data logs are sent to what's called Elastic Metric Services, and that's how we collect distribution information. And then we also register these S3 locations into what's called the Common Metadata Repository, which is the essentially a metadata repository to database. And then on top of that, Earthdata Search accesses CMR, and this is where another way you can access, which I will be giving a demo on. So again, we put these S3 locations in CMR. We put the granules up on S3, and then we also still keep the granules in our databases and web distribution. And we are slowly migrating to this Cumulus system, and we'll be using the full capabilities of the system in the next year or so. Conversely, we all still have all this data on our on-prem web servers as backup for disaster recovery. So I won't go too much into this slide, but this is a bigger picture of all the different systems, which I actually borrowed this diagram from Jesdisk. I thought it was such a great graphic, but it really gives the scope of all the different entities that are involved with the Earthdata migration for all the DACs. And so we have Cumulus, who's done a lot of the development for the ingest and archive system. We have ECC supporting us with infrastructure for code repositories. We then have the LAADS DAAC AWS accounts. And we also have NGAP services, cloud tamer, platforming, and such. And then we also have cloud metrics, common metadata repository, Earthdata login, EDL, Earthdata search, again, EMS for cloud metrics. We have our on-prem system, LAADS DAAC. And then we have infrastructure tools. Slack is one used for communication for the different teams. And then we have the NASA agency, which helps us with authentications and all sorts of other clients. So again, that's kind of just a broad overview. Again, for us, data ingest, Kubernetes on-prem sends to granules. Eventually, we are migrating to the Cumulus system over the next year. Data stored on AWS S3, as well as on-prem for disaster recovery. Metadata is all stored in CMR, Common Data Meta Repository. And then for data distribution, we are currently using S3 Direct Access. This is in cloud only, and for the AWS region US2 only. As I understand, we will be investigating other regions in the future, but right now we are signed up for US West2 only. Again, we're using Cumulus S3 authorization endpoint. And what that does essentially, if you have an EDL or an Earthdata login account, you can exchange your credentials for AWS credentials, and that gives you an hour access window to our S3 buckets. So if you plan on downloading data longer than an hour for those credentials, you'll need to renew them. And that's something you can do pretty easily programmatically within, say, a Python script or something like that. So cloud metrics, that's how we keep track of our distribution. So as people access our data, we keep track of that, and then we collect metrics on that. We have two ways of data search. Again, Earthdata search, which is a kind of visual graphic, which connects also to the CMR search API. CMR, and I'm sure some people have used the CMR search API, which is kind of this link gives the documentation of that. Again, and then for monitoring, we have NGAP, which is doing platform monitoring, security monitoring, Kibana, CloudWatch, and other AWS monitoring tools. So S3 direct access to the LAADS DAAC data in the cloud. So the requirements are you need a Earthdata login account, which you can register for, and I'll show you this in just a little bit on urs.earthdata.nasa.gov. And then you need your AWS account, which allows you then to, once you get your credentials, you can then access the LAADS DAAC SW through this S3 access endpoint. Again, just to stress that this data is available only in cloud through, say, AWS mechanisms such as Lambda, EC2, and is currently available in the US West 2 only region. Instructions and scripts to access this, and I'll go through these in a little bit in the demo. We have our data endpoint README that kind of gives an overview of how to access the data so that we always have a reference for this. And then there's another piece of documentation that shows a shell script. And this is linked off of this other page as well. So you can get to it off of this credentials README if you ever need help on instructions. Again, Earthdata logger credentials are exchanged to AWS credentials in a JSON format. And then you can use those then to access the AWS LAADS DAAC S3 credentials or the AWS S3 endpoint. So I'm going to give a demo and not trying to do two things at once. Tasia is going to narrate and I am going to navigate through the cloud. So I will do that. And then Tasia, if she wants to speak through this.
Thank you, Scott. Hopefully you all can hear me. Is the volume better? I had some.
Yes.
If you can hear, it is. Okay, good.
Yes, I think it's much better. Thank you.
Okay. So I'm just going to start, and thank you so much, Scott, for driving. And let me know if you have any questions afterwards. We'll be glad to answer them. So beyond downloading data from LAADS DAAC directly from LAADS DAAC archive using one of those other methods that are available, LAADS DAAC can also be obtained from the cloud. The first thing that you'll need to do for each user that is trying to get data is to have an Earthdata login account, sometimes referred to as EDL for Earthdata login. You can create this directly with Earthdata by visiting the link in that previous slide, the urs.earthdata.nasa.gov, and click on the register button. If you already have an account, you can log in to verify your credentials with your username and password, which you will need later in the AWS cloud. So On the LAADS DAAC website, there we go. All you have to do is go to Data, and the drop-down menu will pull up these. Click on Cloud, and then this will bring us to our Cloud webpage. Here you can find up-to-date information about accessing data on the cloud, including the benefits of accessing data, explanations of why NASA is moving data to the cloud, frequently asked questions, status of availability of specific data sets on the cloud, and tutorials on how to access data on the cloud. This particular tutorial will explain how to use S3 Direct Access to download data. So from the LAADS DAAC Cloud webpage, you can scroll down or click on the How To link at the top of the page. And here you will find instructions on how do I access LAADS DAAC data files in the cloud. The first section listed there is that S3 Direct Access. At the bottom of that section, so if Scott scrolls down, there are two links. All right, one for accessing instructions for direct access to LAADS DAAC, Amazon Web Services, S3 dataset buckets, and another link for accessing the Earthdata login via the LAADS DAAC S3 credentials endpoint. So those are those README files in that S3 credential link that's also there at the bottom. The first link, the README file, includes instructions on exchanging Earthdata login credentials for AWS session credentials, as well as some code example. So so this is that page. To exchange my Earthdata login credentials for AWS credentials, I'd click on this top link from the README page and open the in-region S3 direct or S3 access to buckets that would generate the endpoint code that is unique to the data user who entered their credentials. The response would look something similar to the sample response in that gray box below, but would be unique to you. So here you will be provided the link for retrieving temporary S3 credentials at that S3 credentials endpoint when authenticated via the Earthdata login. If you click this link, you'd be directed to the login to Earthdata, and once, or if you've already logged in, your credentials will be generated. Okay, so the temporary credentials will include your access key ID, secret access key, session token, and expiration, which will tell you when this token expires. If you're trying to download data after the token expires, you'll need to generate a new token. Tokens are valid for 1 hour. If you're going to be downloading for more than an hour, you'll need to renew that token via the AWS session credentials from that S3 credentials endpoint. So use the temporary credentials in your code when you generate the S3 service. There are sample codes listed on the README page. These are code that can run in Lambda, showing how to access and use the S3 credentials. There are sample codes listed for both Python, and underneath that is for JavaScript. So instead of copying and pasting these codes, data users may find it more beneficial to download the zipped file from the LAADS DAAC webpage and upload it to the Amazon Web Services account. So that zip file can be found on the LAADS DAAC cloud page in the How to Download Data via S3 Direct Access section. The zipped file includes the code that was on that previous page, as well as associated library files that are necessary to run the code. The written instructions are also available on this page for your reference. So let's move over to a data user's AWS account and go through the steps of downloading data via S3 Direct Access in the cloud. So currently, AWS S3 Direct Access to LAADS DAAC data is accessible in the cloud via like Lambda, EC2, et cetera, and in region. So that's just that US West 2 only. This example will run a sample test script with the result of the first 100 files on the bucket. It's meant to be an easy template code that could be modified for all sorts of tasks. So whatever files you need to recall. First, download that S3 Direct Access Lambda zip file to your computer, which we saw on that previous page, and then log into your Amazon Web Services account, which Scott has already done for us here. Under Services, click All Services. And then there's All Services. And then scroll down to L. We're looking for Lambda. All right. Next, select the Oregon US West 2 from the drop-down menu that's on the top right. Then we are going to click on Create Function on that top right. Here, we will be prompted to enter a function name in that field. And we're going to use S3 Direct Access Lambda Test with underscores between each section there. Then we're going to scroll down and change our runtime to Python 3.9. This is just an example, just the version that we used for our test, but others could be used depending on your code. And make sure that you leave all other settings unchanged. Then scroll all the way down and click Create Function. And right now we're creating a function as it spins. Perfect. Next, click Upload From under the Code tab and select the zip file you downloaded earlier from the LAADS DAAC webpage and click Save. So we're going to upload. There's that file that we upload and click Save. All right, so after this file uploads, you'll see the files in the environment section on the left. This environment now holds the libraries from that zip file. Next, we will click on Test and select Create New Event. We're going to enter an event name. This field is required, and we're entering S3 Direct Access Test. Next, enter in the event JSON box the endpoint code that is that was in the gray box on the LAADS DAAC Cloud webpage. But you need to replace your username and your password with your Earthdata login username and password because those are your credentials. Perfect. And then we would click Save. Scott is entering his credentials offline since that is private information and it might take a minute. And Scott will let me know when this is done and we're ready to move on. While we wait, let me remind you of an upcoming Earthdata webinar. Coming up on May 3rd. If you haven't registered yet, you can go to earthdata.nasa.gov, find the webinars and tutorials page, and you'll see it listed there. It is called Lightning in a Flash, using cloud and open source capabilities to improve data access and analysis. And it should be fun. All right. So I know we're still waiting for our code to authenticate offline. Okay. So are we ready, Scott? Oh, I think that Scott's moving on ahead of me here.
Oh, sorry.
So after entering your Earthdata login information into the test configuration code, we'll move on to adding our sample Python code. If the code doesn't transfer from the zip file, you can enter the code on that back page under that code source. You can click on the green plus in the circle and select new file. This will open the tab where you can enter that code. You can copy that Python code from that README file and paste in this section. However, this code is included in the zip file and may transfer in automatically. All right. So next we are going to scroll down to runtime settings and click on edit. and change the handler to S3 direct access .lambda _ handler. This is case sensitive, by the way. And then we will click save. Okay. After changing the runtime settings, we are going to click on configuration, then click edit, and we'll scroll down to timeout, and we're going to change that to 1 minute. Otherwise, the script may time out before it fully runs. And make sure to click save. After changing the we're going to go back up to the top tabs and click code, and then click the test button. Not the tab. Wait for your code to run. And once it completes, a new tab will appear labeled execution results. And the results should be listed of the files on the bucket. And that is how you run the sample code on the Amazon Web Services. This code can serve as a base for you to modify to run your own scripts using LAADS DAAC data. Thank you. And Scott, I'm going to turn it back to you.
AWS, and then you can pull those files or do tasks with that kind of boilerplate code. What this is going to show is how these S3 file locations are now available in Earthdata Search. I'm sure some of you have worked with the system before. So one of the features on here now is that I'm at the Earthdata search earthdata.nasa.gov. I'm logged in with my EDL credentials, and I'm going to click for search for data that are available in Earthdata Cloud. What I'm going to pull up here is one of our most popular data sets, the phase 1 data sets. It's called mod 021 ham. And I'm going to pull this up to give you a description of what this is. It's our Modus Terra calibrated radiances 5-minute. And this is one of our most popular products that is downloaded from the LAADS website. So what I'm going to do is I'm going to go to this data set, click on it here. And if in the past, if you were familiar with this, if you wanted to, so you have all the granules associated with this collection. We've got over 2 million. If I wanted to download this via HTTP access, I would have hit this download button and it would automatic download. But now they've added the capability here that not only you can download the HDF file from on-prem or for AWS 3 access, it now gives the bucket location as well as this S3 location that you can copy and do download. Now, we also have the credentials endpoint and that S3 README documentation in here as well. So this is just another way of getting to those S3 files. If you're doing a search and you're familiar with Earthdata Search, you can find if a data set is available in S3, and then you can actually get to that S3 location. So that's just a quick overview of Earthdata Search. So with that, I'm going to go back and done our Earthdata Search. I'm just going to go up a little bit over our future work in the short term and long term. Again, one of the big tasks that we have is we have this hybrid on-prem configuration with sending data to the cloud. We are planning to migrate more fully to the Cumulus system this next year. We have some prototype ingest workflows that I've been working on. We will do the Cumulus RDS data population, and that work is slated for the end of the year. Another thing we'll be doing is we are looking at migrating post-processing algorithms, subsetting, reprojecting, regridding, reformatting. We're going to take those initial services that we have on-prem and start migrating them to the cloud. And then we're also looking at integrating those with Harmony, which is an orchestration for data services. So a lot of DACs are integrating their services into this Harmony orchestration system. And so we are looking at migrating our services into this integration and comparing against other DAC services so we can start co-locating data services for like subsetting and reprojecting and reformatting. And lastly, we will be looking at web services, refactoring and migrating, and that's going to be starting next year and getting all those services up. In the long term, Oops, excuse me. I'll just sure I did that, but we'll go back down. So in the long term, we have the on-prem software systems that will be refactored and migrated to the clouds. We have that's a monumental task. It's a lot of work. We have 10 years plus of software systems that we need to migrate to the cloud. So we'll be looking at that in the next 2 years and beyond, as well as the databases as well. We have need to migrate those to the cloud. The other thing we'll be doing is looking at recovery systems once we migrate to the cloud. As we migrate those, we will need to look at 2 systems from as this. One is called the Operational Recovery Cloud Archive, and the other one is called the Level 0 Repositories Data Store, LAADS. And we'll be looking at both of those as long-term backup solutions as we migrate to the cloud. So with that, that's pretty much the end of my presentation.
Okay, well, thanks so much, Scott. At this point, I'm going to grab the presenter role back. I am going to get our final polls opened here for everybody. We'll leave these open about 30 minutes or so. So let me get those ready to go. And then we will jump straight in to the Q&A. All right, give me just 1 second here. Okay, I am trying to open these. Here we go. Let's open this poll. Give it about 3 minutes. And there we are. Okay, everybody should be able to see the polls now. All right, so early on we had a couple of questions in the chat. If you could just bear with me for a moment, I am going to tackle those first. We do have our Q&A panelist, Doug Newman, who is on board. And then we also, of course, have our speakers. And so I feel confident they will be able to answer these questions either with Doug or with Tassia or Scott. So give me just a minute to scroll up here to make sure.
Let me do a audio check. Can you hear me?
Yes, I can hear you perfectly. Okay, so
Excellent.
I might just actually read through. I know that you had responded to this earlier, but I do think if there are participants who didn't notice this in the chat, I'm going to go through this comment anyway. We are at the Canada Centre for Remote Sensing, Department of Natural Resources Canada. Used the NASA LAADS DAAC for a long time, both MODIS and VIIRS data. We are very satisfied with this service. Access to cloud storage, Google Cloud of AWS, is not allowed from inside of our departmental network due to security issues. As such, terminating the data access from NASA LAADS DAAC would create significant problems in accessing NASA data, as we will not be able to access cloud from our work environment. And Doug, you did note that all the data is still available via HTTPS. S3 is an additional means of access, but certainly not a replacement. So I didn't know if you wanted to speak to that in a little bit more depth before we move on, but I did want to touch upon that.
Yeah. I'd like to reassert that, actually, to state in no uncertain terms that your current means of data access through HTTPS are not going to be replaced by S3 or any other mechanism. We understand that a large number of our users are either unwilling or unable to leverage these new access mechanisms, and this is why we are preserving free HTTPS access to data. That's not going to change.
Okay, well, thank you very much, Doug. And the next question is, why is it access in cloud only? It ties us to use AWS Compute. Are there plans to open direct access?
Yeah, so you're correct. Right now, direct S3 access is limited to the region in which the data is housed, which is US West 2. The reason for that is that it's a risk mitigation exercise on ESDIS's part, in that currently for AWS, in-region data egress through the S3 API is free. Out of region and out of AWS incurs a cost for that egress. And that is an unbound cost risk to NASA. And as I think it was Tasia mentioned earlier, we are beholden to the US taxpayers to not spend more money than we are allocated. So unbound cost risks are a big problem for us. And this is a simple way for us to mitigate that risk. However, we do understand that there are a lot of users and a lot of use cases who want to use the S3 API for direct access, both out of region, as one user mentioned, is there any plans for making it available in US West 1, and also out of AWS, as another user, another person mentioned, to be able to leverage this in other cloud environments or locally. So we are actually actively searching for different ways to attack this problem. We have a number of solutions in mind, but we are not in a position to act on those just yet or share any more information. But suffice to say, we are aware of this this problem, and we're seeking means to solve it.
Okay, well, thank you very much, Doug. There are a couple, although you did touch upon this, a couple of additional questions in the chat, and I just want to remind everybody, if you have a question, please enter those into the Q&A panel on the right. The first one remaining in the chat is, did you have any estimates, and it sounds like not at the current time, on way AWS S3 direct access to LAADS DAAC will be available for US East 1? It sounds like you kind of basically addressed that with your response, that not currently. The second question in the chat, is there a PHP example to access the cloud?
Yes, I think we have examples in a lot of different languages. I don't have those to hand. Jessica, is it possible that I could give you that information after the fact, and you can publish that information?
Absolutely, I could do that. All right,
Unless
perfect.
Scott, do you have a
I was going to say
script up
Stack
your
Overflow.
sleeve?
I was going to say Stack Overflow. So there's probably an example out there, but it won't be tailored to what you'd have to tailor it more to what we have. But I'm sure there's plenty of examples, and if you have an example, that'd be great.
Yeah.
Okay, perfect. Thank you, Scott, and thank you, Doug. And so the next question in the chat, any plans to make the emit data available on S3? This decision would affect the emit science team proposals, which are due in July.
So I'm not sure which DAC emit is
So the emit data,
publishing.
yeah, so that's LP DAC.
Right. So LP DAC in the process, just like LAADS, but somewhat further along, I think, in putting the data sets onto the cloud. I think any new data sets will go straight to the cloud rather than on premises first. I think I saw Darla Werner on the in the chat. She may have be able to put in the chat some more accurate information from that. But I think if emit is associated with LP DAC, then as a new mission and a new data set, there you go. Darla confirms it. Thank you, Darla.
Okay, perfect.
And
Thanks.
Matt too.
Perfect. Thank you so much. So in a second here, I see that people are continuing to add questions in the chat, but I really do want to get down to some of the questions that are asked in the Q&A panel. So if you would be so kind as to pose your question in the Q&A, that would be wonderful, and I appreciate it. So the next comment here in the chat is... Okay, I'm going to take this last one in the chat. When using stacks to access cogs, is there a straightforward way to ensure that the links are S3 versus HTTPS?
I don't think there's currently a stack extension that deals with this directly. The straightforward hacky way is to pass the URL and see if it starts with an S3 or an HTTPS. That's not ideal. I think there are extensions in the pipeline for being able to make Stack more cloud aware for these cogs. But at the moment, we don't have a lot of cloud optimized formats in NASA Earthdata. That is changing as we recognize the utility of things like cogs, ZAR, Parquet, etc. But if you look at the stack catalogs associated with NASA Earthdata right now for LAADS and LPDAC, etc., a lot of it is going to be in the native HDF, NetCDF format. But that is changing. So I think hopefully the evolution of Stack and various extension is going to change with that and allow you to have a more programmatic and robust way of determining whether you're dealing with an object store or HTTPS.
Okay, thank you, Doug. So I'm going to take the questions in the Q&A, and if we have time during the extended Q&A, I will jump back up to the chat and address those that we have not spoken to yet. So the first question here is, how does this affect the M2M programmatic access? Another question, but unrelated, is a similar transition to the cloud planned for LPDAC in the future?
So the second question, as Dala and Matt pointed out in the chat, is LPDAC are already doing this. They're already going through the migration to the cloud. We currently have our top 75 data sets in NASA Eosys in the cloud, and quite a number of those are from LPDAC, I understand. Dala's probably going to tell me exactly how many in the chat in a second. So in terms of end-to-end programmatic access, we believe we have a solution for that with S3. It was detailed by Scott and Tasia earlier on in this presentation. The process for the other DACs is almost identical. Different S3 endpoints, different S3 buckets, but other than that, it's an identical process. There are a number of areas we think where we can improve. We've mentioned out of region and out of AWS S3 access for those who can't get into AWS or into US West 2. And also, and this was mentioned in the chat, we understand that this 1 hour time limit for your tokens is a problem. Having to refresh those tokens every hour for long-running jobs can be a problem. We're looking at ways of, much the same way that we're looking at ways to increase access out of US West 2, we're also looking at that 1 hour token problem. We have some ideas on how we're going to solve that. Unfortunately, I can't tell you what those are at the time because they're not firmed up yet, and I don't have a timeline for those either. But these are problems that we're well aware of, and the solutions to those are hopefully coming.
Okay, well, thank you very much, Doug. And the next question is, I understand that CMR Stack service catalog assets on both eosdis.nasa.gov and AWS. Is that correct? Okay, so basically, I understand that the CMR Stack service catalogs will be on eosdis.nasa.gov and AWS. I think you mean
So,
Earthdata.nasa.gov, but...
Yeah, I understand. Yeah. So CMR provides a stack API, which will get you stack catalogs for the entire Earthdata archive, both on cloud and on-prem. You can limit it to on cloud if you need to as well. There are some stack catalogs representing data on AWS as well in their open data registry, but they are not native NASA products. There are a few examples of cloud optimized versions of those products that have been developed by or produced by third parties rather than NASA. So there are no actual NASA quote unquote archives on AWS open data at this point. And Dala and Matt have given me the numbers I thought they would. So as you can see, LP DAC is well on their way to transitioning to their cloud archive.
Okay, thank you, Doug. The next question is, do you all support SNS for all of these data?
So basically you're talking about the notification of subscribing to, say, a certain category of data and being notified of new inventory in S3 when that happens. That is not currently available, at least not on an enterprise level. Some DACs may have developed their own solution to that problem, but I'm not aware of those. That is something we're considering in our roadmap, though, the ability to inform users that, for example, there is new data associated with Chesapeake Bay in Maryland, USA. We could notify people and they can subscribe to that topic and then go and get the data in S3. So it's in our pipeline, or roadmap, I should say.
Okay, thank you. So I am going to, let's see here, there's a couple more in the Q&A, then we'll jump back up to the chat. We will be entering the extended Q&A in just 3 minutes here. So are your users at Goddard then not able to pull the data from AWS S3?
Users at Goddard, if they have AWS credentials at their disposal and they have access to US West 2, then they are completely able to use S3 to download data for the data that Goddard has transitioned. They're in a similar situation to LP DAC in that they're partly through their cloud transition.
Well, thank you, Doug. And I just wanted to make this quick note to everybody. We really appreciate all of the feedback that you're providing in the polls. This is super, super useful. So thank you so much for taking the time to provide this input. So the next question is, will data be made available in GeoTIFF in place of NC4 or HDF?
So there's a lot of discussion in the community at the moment and with Esvis about how we make our data more consumable in the cloud. And a lot of that discussion is who will be doing that. We've seen a lot of grassroots initiatives spring up to provide cloud optimized versions of our data sets. For example, cloud optimized GeoTIFFs, Pangeo Forge is a good example of that. The concern on our side is the provenance of the data they produced. Was it produced from bona fide NASA archival data? Were the processes that, or the algorithms used to produce those cloud optimized archives legitimate in terms of accurately reflecting the archived version of the data? So that's very much in flux in terms of who and what we're going to do in terms of making our data more accessible in the cloud. Because we're moving from generally a download to a local file system and the latency profile associated with that to an object store at a remote location, although you may be cloud adjacent using S3 direct access. The archival format that we use, netcdf or HDF, is not conducive to the latency profile associated with S3 object stores, or any object store for that matter. So converting over to breaking up like archive files into smaller elements, like is done with ZAR, or for two-dimensional data with cloud optimized geotiffs using range gets and things like that, is something that we need to invest a lot of effort into solve, and we also need to decide whose responsibility that is. We've always been traditionally seen Eostis as an archive system and preserving archive formats, but that may change now that we're in this cloud environment, and cloud is leveraged more and more by our users. One thing I did want to elaborate on when seeing Tassia's slide listing the reasons that we went to the cloud. You saw a bulleted list there. Was effectively an ordered list, and cost optimization or cost effectiveness was right at the bottom of the list, and data access was right at the top. That is an ordered list as far as we're concerned. The most important reason for us going to the cloud is to make it easier for you users and more efficient for you users to use the data at scale. We think that as time wears on, you're going to need to use more and more data and more processing power to do your science. And certainly being borne out in the areas such as synthetic aperture radar data. The amount of data and the amount of processing required for SWAT, for example, is order of magnitude bigger than what they've had to deal with in the past. So it's, for some use cases, and probably more and more use cases as time goes on, the idea of downloading that data, the amount of time it takes to download that data, the amount of cost of the storage you're going to need on premises, and the amount of processing power you're going to need to produce your science is not going to be cost effective to actually buying that stuff, buying that storage, buying that compute, renting that storage and renting that compute, and being able to rent a lot more of it and a lot more powerful compute over shorter periods of time is probably going to be more cost effective to you, the user. And that's one of the primary reasons we're doing that. Sorry, Jennifer, I went on a tangent there, but I think it was an important one.
No, it's okay. Thank you so much. I do appreciate the additional input. I think participants will find that useful. Okay, so I'd like to kind of combine, because these are related, although two different participants kind of asked the question. So for how long will NASA Earthdata be available in HTTP? And then I think you basically addressed this. The second part of this question is, and when will the cloud data be available to use internationally, like the East Mediterranean region? Because a second user asked, will S3 be the only option at some point in the future?
Right. So we have no plans to retire HTTPX access. We understand that not everybody wants or can get into a cloud environment. So that avenue will always be available as far as I know. We have no plans to limit data access to S3. Even though we're only functioning in one cloud provider at the moment, AWS, the reason for that is when we started this endeavor, we only had the authority to operate in AWS because it was the only cloud environment that could meet our requirements. Obviously, since then, a lot of other cloud providers have sprung up, the big other two being Google Cloud and Microsoft Azure, and we are already investigating branching out into those two cloud providers as well, both in terms of increasing our user outreach and not putting all our eggs into one basket, so to speak, trying to avoid that vendor lock-in problem. We want to be able to have a ability to move between those in cloud environments and provide some degree of redundancy between those two in the future. Those three, I should say.
Okay, excellent. Thank you, Doug. And the next, I've moved back up to the chat, but of course I'll check back down in the Q&A in just a few minutes. You frequently said that you would soon be using the full capabilities of Cumulus. What are the capabilities of Cumulus and what role does it serve?
So Cumulus is enterprise ingest and archive system. It's a means of getting the data onto the cloud and distributing it. So getting it onto S3 and providing a means of distributing it via HTTPS through the thin egress app application that Scott mentioned in his presentation, and also through S3 direct access. It integrates with CMR. So if you think of each DAC having a single account within AWS that their inventory is managed by Cumulus, you can think of that as a big data lake. CMR is the online catalog that prevents that data lake from becoming a data swamp. Whatever you put into that data lake, you can find using CMR. So Cumulus is the data lake in that analogy.
Okay, perfect. Thank you. There was a comment earlier when you were discussing, we're trying to figure out whose responsibility it should be. One of the participants has noted the responsibility should be the DACs. If you are to become a science enabling center, you should have a different mission now.
So that is a very interesting question. As we are moving from individual DACs in geographical locations, storing their data sets, storing their data in that physical location, to them going to the cloud and everything being stored in US West 2, are they still an archive center? And that is something that we're going to have to think about in this new data lake architecture. Of course, obviously the DACs offer tremendous value, not just in terms of archive, but the science support that they provide, the support for those products as well. So I'm not going to get into the discussion about science enabling centers though, because that's quite a hot topic, if you don't mind.
Okay, thank you, Doug. So the next question is, will there be a time where there'll be a timeliness delay between getting data from the cloud and HTTPS? What about ESA's data sets like Sentinel-3?
So we do have some replication of Sentinel data, I believe. LPDAC is one example of that. This is a problem that we have cross agencies, where in order to do this harmonized kind of science, like between Landsat and Sentinel, you want both of those data sets adjacent to your compute, and that usually means in the same region. Landsat data sets are in US West 2. The original location of Sentinel data sets is in Europe. So one solution to that is to mirror those archives. And we've done some work. Yes, Sentinel is at other other archive centers as well as Landsat, that is true. So mirroring is one solution. One other solution is taking the compute to those cloud environments, but as several people on this presentation pointed out, there are some limitations to that for a variety of reasons, where users are limited in their choices of where they can put the compute. So there's that sort of interagency collaboration is a problem to be solved. We've got a number of ideas on the mirroring for one, but we're not there yet.
Okay, thank you. Thank you, Doug. I was just scanning both the chat and the Q&A to see if I have missed any questions. There was a request early on, and the comment by the participant is there's a script demo for MATLAB, and please, can you sign the link? I'm not really sure exactly what this means, but and please can you sign the link on how to find the demo script for automatic downloading? So perhaps asking to include the demo script link for automatic downloading. And I'm not sure, maybe if this participant could add a few additional details, or do you get the general gist of this, either Scott or Tassia or Doug?
Are they looking for
I'm not familiar with the script.
the Lambda script or the script examples off of the S3 credentials README?
Marco, if you are still online, if you could, clarify which script you're looking for. So the slide deck does have links to the content that was provided today, and I can certainly follow up offline as well and connect you with our speakers to provide that access that you're looking for. Okay, so I didn't want anybody to think that I don't want to skip over anything. Let's see, I think we have tackled everything in the chat. And just as one final look in the, okay. We do have another question. We can generate terabytes of data per day and make it instantly available. What is the expected throughput of uploads to AWS? Will we have a dedicated pipe?
I don't have offhand the current throughput of ingest into AWS, but we don't have a dedicated pipe for that ingest or for that distribution. But AWS can handle it without that dedicated pipe. They'll just charge us for it. So the problem from our perspective isn't, is AWS going to be fast enough? It's are they going to be too fast, and are there going to be too many users, and we're not going to be able to pay for it? So the problems are with us, not us being NASA, not with you being the users, hopefully.
Thank you, Doug. And okay, so as a follow-up, the user is looking for a link to the script when you were going over the Lambda functions. Scott.
Okay,
So
yes.
maybe we can
So that there is a link in the how-to section of the our web page, the LAADS DAAC cloud web page. If you look down in the how-to direct through S3 access directions, there's a link to that Lambda zip file that you can download.
Okay, and I'm going to put the link to the clouds page in the chat one more time. Hopefully this really helps. Let's see. All right then. And yes, and then there's a comment, AWS has an extensive set of training materials and tutorials. Many are free or are low cost. And also, many of our data centers have put together some cloud computing, data learning pages where they have linked to various tutorials. And I can certainly provide that information as well offline. Just scrolling through here because I thought I saw something else here. And then the follow-up comment based on the dedicated pipe, the participant is noting, if you're able to, you're better off without a dedicated pipe.
Yeah.
All right, so we're going to give this, we have kind of wrapped up with our extended Q&A. What I will do at this point is leave the virtual space open. If somebody thinks of something that you'd like to add into the chat, or you have a question, I will be forwarding the Q&A logs as well as the chat to our speakers as well as our Q&A panelists. So certainly if you think of something, we didn't address it during the webinar framework today, they'll be able to address that with you offline. And I think we've got maybe only a few more minutes left of the polling questions. No, we have ended that as well. So at this point, I'd like to thank our Q&A panelists, Doug Newman, and our speakers, Tassia Owen and Scott Longmore, and thank all of you for all of the feedback you've provided today. Again, super useful as we go through these transitions. And with that, we'll log off from the audio component, and I'll leave the virtual meeting space open. So thanks so much, everybody. We hope to see you at an upcoming webinar. And with that, have an enjoyable rest of your day or evening, depending upon where you are, or perhaps even morning. All right, take care, everybody. All right, goodbye now.
Thank you.
Thank you,
Bye.
Doug.
You.
All right, see ya.